Today we will see solar photovoltaic system. So what is solar PV system? A solar PV system is a system which captures the sun's energy and they converts it into useful energy, that is electricity. Now we can see how solar cell works. So here when sunlight strikes the solar cell surface, the cell creates a charge carrier as electrons and holes. The internal field produced by junction separate some of the positive charges from negative charges, and here the holes are swept into positive or p layer and electrons are swept into negative or n layer. When circuit is made, free electrons have to pass through the load to recombine with the positive holes. Thereby current can be produced from the cells under illumination. Now we can see the components of a PV solar system. It typically consists of four basic components: PV array, batteries, inverter and charge controller. So the first element is PV array. What is PV array? Actually, the electricity is generated by solar cells. So individual solar cells are grouped together into a solar panel, or we call it as a module. Then several modules are grouped together to form a PV array. So first cells are grouped together to form a module. These modules are grouped together to form a PV array. The factors affecting solar panels are the temperature, shading and the types of solar panels are single crystal or monocrystalline silicon, polycrystalline or multicrystalline silicon. And here both mono and poly solar panels serve the same function. They capture solar energy from the sun and turn it into electricity. And they both made from silicon, which is used for solar panels because it's an abundant, very durable element. One is monocrystalline silicon module. They are commercially available module. The main advantage of monocrystalline panel is its higher efficiency and they are most expensive one. Second one is polycrystalline silicon module. They have lower efficiencies than monocrystalline options, but the advantage is a lower price point. Second component of a solar PV system is battery. The batteries in the solar PV system stores the energy produced from the PV array and they will deliver it to the inverter which supplies the load. A group of batteries in a solar power system is called a battery bank. So coming to the battery care, usually charge controller must be set to cover presets different type of battery and battery requirements, and battery should be kept topped up with distilled water because normally distilled water is used to dilute acids. So but we don't use normal water because it contains metal ions which react with acids and electrodes and causes of degradation in charging capacity of battery. So the third component is a charge controller. Charge controller or charge regulator, battery regulator, it limits the rate at which electric current is added to or drawn from electric batteries. Actually, it regulates the voltage and current coming from the solar panels going to the battery. So you can see the features of a charge controller. The feature is maximum power point tracking. MPPT stands for maximum power point tracker. Actually, this is a circuit employed in the majority of modern photovoltaic inverters. Its function is to maximize the energy available from the connected solar module arrays at any time during its operation. And the second feature is shunting. Actually, this diverts the excess electricity to a shunt load when batteries are full. So, example, DC loads like DC fans, lights, etc. The last component is inverter. Actually, inverters play a crucial role in any solar energy system and they are often considered to be the brains of a project. So actually the power produced is DC. So here this power needs to be converted to an AC or alternating current before it can be connected to the utility grid or delivered to the AC load. So the inverter, what they do, they changes the direct current to alternating current. And two types of inverters are the off-grid and grid-tied. So in general, we can say the different components of solar PV systems are solar array, charge controller, battery, inverter. Okay. So first one, solar module. It's an essential component that converts sunlight directly into DC. Then comes solar charge controller. They regulate the energy flowing from the PV array and transfer directly to the batteries. Battery, they do accumulate the excess energy created by the PV system and store it and to be used at night or when there is no energy input. And comes the inverter. It converts the variable DC output of the PV solar panel into AC. And lightning protection, they do prevents electrical equipments from damages caused by lightning or induction or high voltage surge. And different solar system are grid tied system, off grid, and a grid tied PV system is an electricity generating solar PV system that is connected to the utility grid. Advantage of using grid connected solar PV system are they are easier to install as they do not require a battery system, little maintenance required, and they can save money due to net metering. A grid connected PV system mainly consists of solar panels and inverter. And off-grid systems, they work independently of the grid, but they do have batteries which can store the solar power generated by the system. The system usually consists of solar panels, battery bank, charge controllers, and inverters. Drawbacks of the off-grid system are an off-the-grid system can cost a bit more than a grid-tied system, and another drawback is that it requires more maintenance. The third type is hybrid solar PV system. It's a combination of grid-tied and off-grid solar system. Actually, can be described as off-grid solar with utility backup power, or we can call it as a grid-tied solar with extra battery storage. And some hybrid system also have a backup generator tied in with the system. So the hybrid system mainly consists of PV panels, battery bank, charge controller, inverter, safety gear like fuse breakers, etc. Then it requires monitoring system to monitor the energy production. The hybrid solar energy systems have various advantages like continuous power supply. The hybrid system usually they provide power continuously without any interruptions as the batteries connected to them to store the energy. So when there is an electricity outage, the batteries work as an inverter to provide a backup. And this is also the case during the evening or night time when there is no sun and energy is not being generated. Batteries provide the backup. And the second advantage is that it requires low maintenance. Actually, the maintenance cost of the hybrid solar energy is low when we compare with traditional generators which use diesel as fuel. Actually, here no fuel is used and they do not require any frequent servicing at all. And high efficiency is a third advantage. Usually, they work more efficiently than traditional generators which waste the fuel under certain conditions. Usually the hybrid solar systems they work efficiently in all types of conditions without wasting the fuel. PV arrays can be mounted on rooftops, ground or another type of structure. Some of the consideration for the array location are we have to select a location that has maximum sun exposure and limited shading throughout the year. And the panel must be installed facing south and should be tilted at an angle equal to the latitude of location. Advantages of a grid system are the sustainable nature of solar energy and they do not harm the environment. That is, the environmental impact is minimum. The customer can install in his premises, so over a period of time he gets the electricity for free. And coming to the lifetime, it's over 30 years. And maintenance also is minimum. Maintenance only required in cleaning solar panels regularly, and the operation is also silent. Coming to the drawbacks, the major drawback is high installation cost and low energy efficiency.